Hello guys, how are you today? So today I'll be explaining the chemistry AMS of term 2, week 13. Okay, so an aluminium alloy is used instead of pure aluminium in aircrafts. Why is aluminium alloy used instead of pure aluminium? First of all, a main reason why we use alloys instead of pure metals is that usually alloys have more features that we need than pure metals. For example, they could be more reactive if we need them to be less reactive. They could be stronger. They could have a higher melting point. Just in general, these are some of the reasons why we use an aluminium alloy. However, if we're gonna use them in aircrafts, let's think logically. If it's more abundant in nature, how does this benefit us? For sure, this doesn't benefit us, and it does not benefit us. So like it's in between. It's a gray area, if you want. Okay. So if the alloy is more reactive than pure aluminium, so imagine you are in an airplane made out of something that's more reactive. For sure, it's gonna react with the surroundings and it's not gonna sustain, it's not gonna last. So for sure, this is wrong. If it has a lower melting point than pure aluminium, then what's its use? It's gonna melt directly without using it. Finally, aluminium alloy is stronger than pure aluminium. For sure, this is a good benefit, a good use. Okay, so we move on to question number 2. We talk about transition metals. They said, what are the general properties of transition metals? What do you need to know about transition metals? It's that they are denser than other metals. They have more than one oxidation state. Okay. For example, Fe, you can take Fe2 plus or Fe3 plus. All right. They have catalytic properties. Catalytic properties. Okay. They form colorful compounds. Colorful compounds. And they have high melting points. So keep these in mind. That transition metals are denser, they have more than one oxidation state, they have catalytic properties, they form colorful compounds, and they have high melting points. So here they're denser than other metals, they have catalytic properties, they have a higher melting point, they have more than one oxidation state, and they form colorful compounds. We move on to question number 3. Why is cryolite added to bauxite during electrolysis? Okay, what you need to know over here is that cryolite, whatever you add it to, it's gonna lower its melting point. So cryolite will lower the melting point of bauxite. Now, why do we use bauxite? We use bauxite to extract aluminium. Now, I know some people write aluminium like this. This is personally how I write it. Other people write it like this, aluminum. But in the exam, they will take it as aluminum, not aluminium. So keep in mind not to write it as aluminium, write it as aluminum. All right, so for the extraction of aluminum, we will use bauxite, okay? And we add cryolite to bauxite to lower its melting point. We move on to question number 4. Which of the following is an industrial process for the production of hydrogen? You should know that for the production of H2, we have 2 methods. The first method is the steam methane method, okay, or the methane steam, either is the same. And then the second method is the electrolysis of HCl or acids. So it could be HCl, it could be H2SO4, whatever it is, as long as it has H in it, it will produce H2 gas. So we said reaction between methane and steam, which is steam methane reaction, and the electrolysis of hydrochloric acid or any acid. So these two will work. Okay, we move on to question number 5. They said an alloy is a solution of a metal with other metals or non-metals. Which of the following best describes the structure of an alloy? Whenever we're discussing an alloy, what you need to see? You need to see 2 key terms. The first one is replace some atoms. So they will not replace all the atoms, they will replace some of the atoms. And the second one is to occupy spaces. Okay? So atoms of another metal or non-metal replace some of the host metals. This is for sure an alloy. They form a layer. This is not an alloy. This is electrolysis. They repel host atoms. This is not an alloy. They occupy spaces between neighboring atoms. This is an alloy. So these two so far. And then they replace all the host atoms. This is incorrect. They only replace some of the host atoms. Okay. For question number 6, how is oxygen prepared in a laboratory? How do you prepare oxygen in a laboratory? Very simply, you're going to take hydrogen peroxide. Okay, it is going to decompose and it's going to give us two products, which is water, H2O, and oxygen, O2. So keep in mind, hydrogen peroxide will decompose to give us H2O plus O2. So it will decompose to give us water plus oxygen. So the catalytic decomposition of hydrogen peroxide. We move on to question number 7. Now question number 7, this is a blast furnace. You should remember that in the blast furnace, what happens? We are extracting liquid iron. Okay? So usually our resources, they are what? They are hematite, okay? They are any iron ore. So we're just gonna write here resources. They are iron ore, okay? In addition to coke, in addition to limestone, in addition to hot air. Okay, let me fix my plus 1 second. In addition to hot air. Okay, so the whole process in a blast furnace is to extract liquid iron. Our resources are iron ore, coke, limestone, and hot air. Okay, what are these steps? This is very important. These steps are very important. Keep these in mind. The first step is the combustion of coke. Okay? The combustion of coke, its chemical formula is C solid plus O2 gas is going to give us CO2 gas. The second step is the reduction of the ore. Reduction of ore. The reduction of the ore, it is the iron ore plus carbon monoxide gas. Okay, it is going to give us iron liquid in addition to carbon dioxide gas. And then finally, the third and final step is the formation of slag. Okay, the formation of slag, very simply, its chemical equation is CaO solid plus SiO2 solid is going to give us CaSiO3 liquid. And keep in mind that the major impurity in all of these, it is carbon. Okay, this is just a summary of the blast furnace. So in the blast furnace, which of the following are mixed with hematite? Hematite is the iron ore. Before being introduced from top of the surface, we know that it's mixed with coke and limestone and hot air. But since hot air is not an option, we will not choose it. We will go down to the substance that's introduced from the bottom of the furnace. It is hot air. Now here we have to write a series of reactions that occur in the blast furnace. And we need to give the chemical equation for each of the following. We said the first one is to give the chemical equation for the formation of carbon dioxide from burning coke. We said the first process is the combustion of coke. So it's going to be carbon solid, okay, is going to react. So in addition with oxygen gas, O2 gas, to form CO2 gas. So keep in mind the coke, which is carbon solid, will react with oxygen gas to produce carbon dioxide gas. Okay, now for the second part, they said give the chemical equation for the reduction of carbon dioxide after reacting with excess coke. Okay, so here what they are saying is that we need to write the chemical equation of carbon dioxide. So carbon dioxide, that is CO2 gas in addition to, so it will react with excess coke. So coke is a solid, and it will form what? It will form carbon monoxide, and carbon monoxide, it is a gas. So it will form carbon monoxide gas. This equation is not balanced. To balance it, you will put a 2 over here. So carbon dioxide gas will react with excess coke, C solid, to produce 2CO, 2 carbon monoxide gas. Now here, we are dealing with the reduction of the ores. Give the chemical equation for the reaction of hematite with carbon monoxide. The first thing you should know is that you will always put the iron ore. So the iron ore, it is Fe2O3, and usually the iron ores, they are a solid. It is gonna react with the carbon dioxide gas plus CO gas to produce, keep in mind, all of this is to extract liquid iron, so it will produce liquid iron. Here, I believe there is a mistake, if I'm not mistaken. Here, they put 1 instead of liquid, so it's gonna show up as wrong, but put L, not 1. Okay, put L in the exam. So, iron liquid plus CO2 gas. So, keep in mind that the iron ore, Fe2O3 solid, plus carbon monoxide gas, it is gonna form iron liquid in addition to carbon dioxide gas. Now, as you see in this equation, it's not balanced. So, to balance it, we will need to put a 3 in front of the carbon monoxide, a 2 in front of the Fe liquid, and a 3 in front of the CO2 gas. So you will balance it. Of course, you should balance it on a paper. But do not forget that it's Fe2O3, the iron ore, which is always solid, in addition to the gas, which is carbon monoxide gas. It will give us 2 liquid iron. This depends on what the reaction is, of course. This will give us liquid iron plus 3 CO2 gas. Okay? Please do remember to balance it. Now, finally, the last one is the formation of slag. They told us calcium oxide, CaO, which is always a solid, will react with silica impurity, SiO2, okay, which is also a solid, to form slag. Slag, it is CaSiO3, but it is a liquid, so do not forget to put liquid next to it. Now, finally, in part D, the iron obtained from the furnace is called cast or pig iron, and the major impurity, as we said before, it is gonna be carbon. Alright, so we'll move on to question number 8. In question number 8, they said when hydrogen gas comes into contact with a light splint. So what you need to know, okay, about the gases, we have H2, we have CO2, we have Cl2, and we have O2 gas. So the H2, it will make a popping sound or a popping noise. The CO2, it will turn lime water milky. So lime water becomes milky. Cl2 will bleach litmus, so bleaches litmus paper. And then finally, the O2 gas will relight a glowing splint. So relights glowing splint. Okay? Okay, so keep in mind that H2 makes a popping sound, okay, with a lit splint. CO2 will make lime water turn milky, and Cl2 will bleach litmus paper, and then finally O2 gas will relight a glowing splint. So for here, it will make a distinctive popping sound. We move on to question number 9. In question number 9, they said, write an equation to represent the decomposition of hydrogen peroxide. So hydrogen peroxide, we know that it is H2, okay, O2. It will decompose to form water, which is H2O plus O2 gas. As you can see over here, it's not balanced. So to balance it, we're going to put a 2 in front of the H2O2, okay, and a 2 in front of the H2O, and just like that, it's balanced. But now we need to include the state symbols. H2O2, it is always aqueous. 2H2O, it is liquid. And finally, O2 gas, it is just O2 gas. So what you're going to write is 2H, my bad, I dropped my pen, 2H2O2, okay, and it is an aqueous, all right, it will decompose to form 2H2O liquid. I put solid, I meant to put liquid, my bad, my apologies, in addition to O2 gas. Okay, and always the catalyst that is used in the decomposition of hydrogen peroxide, it is MnO2. Keep in mind that it is MnO2. I skipped a question. We move on to question number 10 here. This is very simple. Organic water pollutants, they are sewage water and pesticides. Inorganic water pollutants, they are heavy metals and inorganic fertilizers. Okay, we move on to question number 11. Here we need to know which one protects the metals from corrosion. The metal to be protected is connected to a more reactive metal. When it is connected to a more reactive metal, this is sacrificial protection. So always look for the key words. Connected to a more reactive metal, sacrificial protection. When it is coated with another metal, this is electroplating. And finally, when it is coated with the zinc, then this is called galvanizing. We move on to question number 12. This is a very, very important question. I will write for you the elements in order of their reactivity. So we have, first of all, potassium K being the most reactive, then Na, then Ca, then Mg, Al, Zn, Fe, Pb, H, Cu, Hg, Ag, Au, and Pt. So this is in order of reactivity. Now the last two, I will move them. Let me just like make Pb a bit smaller. So it would be Pb, then H, Pb, H, Cu, Hg, Ag, Au, and Pt. Now, what you need to know is that from down to up, the reactivity increases. Okay, that means the most reactive is potassium and the least reactive is platinum. Alright, so here they told us that aluminium is blank reactive than iron. Aluminium is Al, so it's over here in this level. Iron, it is Fe, and it's in this level. So very simply by looking at it, you can see that aluminium is more reactive than iron. So it will react faster or rapidly with oxygen to form a thin coat of aluminium oxide that prevents further corrosion. That's it. We move on to question number 13. And question number 13 here, this is a very interesting question. So they said, drag and drop the terms below to relate to the given properties of aluminium to its usage. So, low density of aluminium. If aluminium has a low density, then for sure we need it to be used in building aircrafts, because aircrafts, they need a low density for them to float in the air, to float with the wind, if you want. Okay, excellent thermal conductivity. When you are using excellent thermal conductivity, it has to be used in cooking utensils. So using a pot, for example, you use metal because it has excellent thermal conductivity to cook the food. Then we have for excellent electrical conductivity and lightweight and malleable, this we will use it for electrical wiring systems for sure. Unbreakable and unreactive oxide, this could be for food packaging because if it's unreactive, it will not spoil the food. And finally, strong, light-weighted, and shiny, we could use this in the building industry. We move on to question number 14. So in question number 14, we have that aluminium is extracted by the electrolysis of molten aluminium oxide, which is aluminium ore, or aluminum, dissolved in another substance. A schematic diagram of the apparatus used is shown below. All you need to know about this question, okay, is that when we are extracting aluminium, okay, when we are extracting aluminum, we have the cathode being the negative electrode, Okay, it will undergo reduction, and in the cathode we will get the aluminium, we will get the pure aluminium. So by extracting aluminium in the process, in the cathode, which undergoes reduction, we will get the pure aluminium. And the equation that happens, it's Al3 plus in addition to 3E minus, and it will give us aluminium Al. So Al3 plus in addition to 3E minus, so it's gaining electrons, which is the definition of reduction, and then it will form aluminium. For the second electrode, which is the anode, which is the positive electrode, it will undergo oxidation. Okay, and oxidation will lose electrons. So what will form in the anode? Very simply, O2 gas will form in the anode, and the equation is that 2O2 minus will give us O2 in addition to 4 electrons. Just keep these in mind, okay? And if they ask for the overall reaction, very simply, it's gonna be aluminium oxide or the aluminium ore, which in this case it is 2Al2O3. Okay, it is a liquid because we put it as a molten. So we put it as a molten in the mixture. So the electrolyte, it is a molten mixture of aluminium oxide. Okay, it will give us 4 aluminium that is liquid in addition to 3 O2 that is a gas. So the overall equation, it is the molten mixture of aluminium oxide, so 2Al2O3 liquid. It will give us liquid aluminium, pure liquid aluminium, which is 4Al liquid, in addition to 3 oxygen gas, so 3O2 gas. So very simply, molten aluminium is produced at the cathode. Okay, now at the cathode, the reaction, it is Al3 plus, it's not typing, so Al3 plus in addition to 3E minus, okay, and it will form aluminium that is pure. And at the anode, we will have 2 oxygen, 2O2 minus, okay, and it will give us what? It will give us oxygen, O2, in addition to 4 electrons. All right, now the overall chemical equation, as we said before, it is 2Al2O3, which is the molten electrolyte. Okay, it is gonna give us 4 aluminium that is liquid, so pure aluminium that's liquid, in addition to 3O2, which is a gas. Now, the anode is made up of graphite, has to be regularly replaced. Why? Because the graphite will react with oxygen, so it will react with the oxygen gas produced. Now, choose a substance mixed with aluminium oxide to lower its melting point and consequently lower the cost of operating the cell. Very simply, whenever you see lower the melting point, you will directly think of cryolite. That's it. We move on to question number 15. Choose the air pollutant that is mainly released from each of the following resources. So, sulfurized fuel, remember keywords, sulfurized fuel, directly to sulfur dioxide. When you see jet engines and internal combustion, this is directly nitrogen oxides. Combustion of carbon-containing fuels, this is carbon dioxide. When you have decomposition of vegetation and waste gases from animals' digestion, especially cows, this is methane. And finally, the incomplete combustion of fuel, okay, this is carbon monoxide. So, sulfurized fuel will give us sulfur, jet engines will give us nitrogen oxide, complete combustion will give us carbon dioxide, decomposition of vegetation and waste from animal gases, especially cows, is methane, and finally, incomplete combustion will give us carbon monoxide. In question number 16, we have choose the name of the process occurring at each step of the given water treatment course. So in step A, we have bacteria, large solids, fine solids, and then it becomes only bacteria and fine solids. So the first step is for sure screening, because you're getting rid of large solids. The second step, we're getting rid of bacteria. To get rid of the bacteria, we call this process sterilization. And then the final step, which is step C, we got rid of fine solids, so we call this filtration. Okay, so screening, sterilization, and filtration. Choose the step that involves addition of chlorine or exposure to UV light. This is usually sterilization, so it is step B. We move on to question number 17. Okay, here you just have to memorize. Whenever you see upon the addition of water, the salt will change color, directly you will think it is anhydrous. Anhydrous, it will not absorb the water. So hydrated is for sure wrong. So the answer is definitely for sure anhydrous. And when it is moving from white to blue, this is anhydrous copper sulfate. And when we are moving from blue to pink, for sure it's gonna be anhydrous cobalt chloride. So anhydrous, whenever you see that the color changes, okay, and from white to blue it's copper sulfate, and from blue to pink it is cobalt chloride. We'll move on to question number 18. Here we have write the chemical equation for each of the following methods with oxygen gas. Do not include state symbols in your equation. Use the smallest whole numbers to balance the equation. So we have potassium K will react with oxygen to form. We know that potassium, its ion is K plus, and oxygen, its ion is 2 minus. So K plus O2 minus, do the crisscross method, you will get the product, which is K2O. As you can see, it is not balanced. So to balance it, we will add a 4 over here and a 2 over here. So very simply, it is 4K reacts with O2 to form 2K2O. We move on to magnesium. Magnesium, Mg, will react with oxygen to form Mg2 plus O2 minus, crisscross method, MgO. It is not balanced. So to balance it, we are very simply gonna add a 2 in front of the Mg and a 2 in front of the MgO. So 2Mg will react with O, 2O, always keep it capital. So this was a mistake. I don't know how this happened. Okay, let me just so 2Mg will react with O2 to form 2MgO. Now finally, iron Fe. Fe will react with oxygen, O2, to form the compound Fe. They said it's Fe3+. So Fe3+ will react with O2 minus, crisscross method, Fe2O3. Okay, so the product is Fe2O3. So as you can see, it is not balanced. To balance it, very simply, we are going to put a 4 over here, a 3 over here, and a 2 over here. By now, you guys should know how to do the balancing. So the final answer is 4Fe will react with 3O, react with 3O2 to form 2Fe, 2O3. Okay, so that is it for question number 18. We move on to question number 19. So, question number 19. The gas that composes 78% of air, here you should know it is nitrogen gas. 21% of air, it is oxygen gas. But as you can see, if you add them together, 78 plus 21, you put your calculator, 78 plus 21, you're left with 99. So there's still 1% left. This 1% is made of water vapor, of noble gases, and of carbon dioxide. We move on to question number 20, which is the last question. So oxygen is colorless and odorless gas. It belongs to which group? If you come over here, okay, and you search for oxygen, you will see that it is in this group over here. So let us see which group it is in. This is group 1, group 2, group 3, group 4, group 5, group 6. So it is in group 6. Okay? My bad for that. So it belongs to group 6. And if you put it in Roman numerals, it is VI. So anything that comes before V, this is subtraction. Anything that comes after V, this is addition. So if they give you IV, this is 4. I is 1. V is 5. So 1, 5, 5 minus 1 will give you 4. Okay? But if they gave you VI, it's gonna be 5 plus 1. This will give you 6. Okay, so this is in group 6. So because it is in group 6, it will have 6 valence electrons. And very simply, oxygen, it will relight a glowing splint. That's it. Let's submit. And hopefully there are no mistakes other than this one particular question. Okay, let us see. Thank God there are no mistakes. This is the only question that is considered wrong because, as you can see in question number 7, okay, let it come. So question number 7, the whoever made the exam put it 1, and it's supposed to be liquid, not 1. So this is the only mistake. Thank you guys for watching. I hope you enjoyed and have a wonderful day.